These are the hardware connections for the DC motor project in Fresno State's microcontroller course. The project controls both the speed and direction of a DC motor using a PIC and a 12-volt battery. The PIC was programmed using a custom-developed code as shown in the previous video in MP Lab. Once the code was created, it was transferred as a hex file onto the board using the program PIC-Kit2 through a USB. This block diagram shows the laptop connected to the PIC through a USB, along with the PIC powered by a power supply and a 12-volt DC battery. This also shows the connections for the DC motor. These are the connections established to run the DC motor on the PIC board. Table 1 shows the MCU interface to FET via optical isolator. The left shows the port connections and the right shows the pin connections. Table 2 shows the power supply connections for a 12-volt DC battery. The left side shows the pin designations, while the right side shows the FET pin designations. Table 3 shows the connections established for the DC motor. The left side shows the DC motor connections, while the right side shows the FET connections. This page shows the clock connections for the PIC board. The PIC board clock connections were established by going to SW4 and pinning those onto port A. This diagram shows the hardware connections on the board's outline. Here you can see the outputs and the inputs along with the clock connections we just saw above. This is where the 12-volt DC battery will be applied, and here are the motor terminals for the DC motor. Here you can see the H-bridge connections on Q3, Q4, Q5, and Q6. Finally, here is an image displaying the connections once they have been established. Here you can see the 12-volt DC battery, the PIC board, along with the inputs and outputs, and the DC motor. This concludes the hardware connections for the DC motor project created in Fresno State's microcontroller course.